Hello everyone, welcome to this video lesson. In this video lesson, we are solving a problem from a topic called friction. The problem is like this. There is a block of mass 4 kg placed on a rough horizontal surface. Time dependent force F equal to kT is acting on the block where K is 2 Newton per second. So this is how it is. There is a body on a rough horizontal surface, of course, whose mass is 4 kilograms. On this now there is a force acting, F equal to kT. Of course, K value is given like 2, so F is simply 2T Newton. So it is obvious that the frictional force will try to oppose the relative motion acts against the applied force. If the applied force is more than the frictional force, body will move from left to right. We have to calculate what is the frictional force between the block and plane at t equal to 2 seconds. First of all, let us try identifying what is the maximum possible static frictional force is. I can write Fs maximum, which is also called as the limiting frictional force, as mu into normal reaction. What is normal reaction? Applied force applies a weight on the lower surface that is in contact in the downward direction. The surface applies a reaction on the body in the upward direction, normal to the reaction, which is called as normal reaction. So normal reaction in terms of magnitude is equal to the weight of that body itself. He has given that coefficient of friction is 0.2. Mass of the block is 4. Assume G equal to 10. So it's going to be 8 Newton. This is a maximum frictional force. Fs maximum is 8 Newton. Now we have two cases in the problem. Case 1, when time is 2 seconds, then F applied is being kT. K is given as 2, T is also equal to 2, 4 Newton. So in this case, on the body, there is a force of 4 Newton. Friction cannot become Fs maximum because when the applied force is less than Fs maximum, static frictional force will self-adjust itself to the applied force and keeps the body in the state of rest itself. It is ridiculous to say that friction will become 8 Newton here and the body move against the direction of applied force. That's not possible. Body has to move either in the direction of applied force or in the state of, has to remain in the state of rest. That implies frictional force in this case is self-adjusts to applied force. As the applied force is 4 Newton, frictional force also becomes 4 Newton. Both of them cancels and body remains in the state of rest. So in this case, frictional force is nothing but applied force 4 Newton. Now there is another case. What is that another case is? Say for example, case 2. When t equal to 5 seconds, then F applied will become K is given as 2, F equal to kT, 10 Newton. So the body will be on the horizontal floor. Applied force is 10 Newton. Frictional force will reach its maximum. That's nothing but equal to 8 Newton. So in the second case, as the applied force is greater than Fs maximum, friction also will reach to its maximum, 8 Newton, and it cannot increase more than that, it stops there itself. As the applied force is more than the frictional force, body will move in the direction of force. So in this case, frictional force is nothing but equal to 8 Newton. Acceleration will exist because there is a resultant force, applied force minus frictional force. Applied force is 10, frictional force is 8. Body of mass 4 will acquire an acceleration here. So 2 equal to 4 into A, acceleration is 2 by 4. It's 1 by 2, that's 0.5 meter per second square. So body will acquire some acceleration here. That's it. So this entire problem is to explain that there is a force called static frictional force which self-adjusts with respect to the applied force. If the applied force is less than Fs maximum, then the self-frictional force will self-adjust itself to the applied force and keeps the body in the state of rest itself. That's it. Thank you for watching. Keep coming back for more and more video lessons. Thank you.